Greetings and welcome to Week 3, Unit 5, Scope and Limitations of Cognitive Processes. In the previous unit, we understood the cognitive process, evaluate and create of revised Bloom's taxonomy. In this unit, we want to look at the cognitive processes of revised Bloom's taxonomy in relation to many things that we do and whatever reservations people have about that, we will try to address some of them. To what extent whatever statements that we are making about the cognitive domain are valid or not, or where there are uncertainties, we'll point them out. Okay. One of the things that people often talk about is the word critical thinking. And if you look at most of the policy statements they make, we keep on saying that the student should be trained to critically think. Actually, not giving any scope at all in practice to train and test the students for critical thinking. Time is never available for this, but everyone wants everyone to critically think. Okay, now the question is critical thinking is another cognitive level other than what we have dealt with? Should it be added? Is it a drawback for the revised Bloom's taxonomy? For that, we need to understand first what is critical thinking. A lot of work has been done in this area. There is even an organization called criticalthinking.org. It is actually a group of professors from different universities in USA. They got together and they considered critical thinking, training in critical thinking is very important for either at school level or at higher education level. And they have been debating, having conferences, they produce a lot of material, they produce small manuals, and I'm trying to present what that group is considers what critical thinking is. Critical thinking is the active, disciplined process of analyzing, evaluating, and synthesizing information to make reasoned judgments and solve problems effectively. It involves not just accepting ideas at face value, but questioning assumptions, identifying biases, recognizing logical fallacies, and considering alternative perspectives before reaching conclusion. Okay, that is what, as you can see from the wording, that we are using most of the words from multiple levels of multiple cognitive levels. Okay, another modification of that, the ability to identify and question technical assumptions, interpret data, evaluate design alternatives, and propose logically sound and ethically responsible solutions to real world problems. The first one is broad definition of critical thinking. If you particularize to engineering disciplines, this is what would come out to be. The second one. Okay. Now further, if you look at key characteristics of critical thinking, what is involved? As you can see from the definition, there is analysis. Analysis involves breaking information into parts to understand structure and meaning. Evaluation, judging the credibility, relevance and logic of information and arguments. So evaluate is there. Then inference, drawing logical conclusions from available evidence. Explanation, clearly and correctly articulating reasoning and evidence. So, infer and explain belong to the category of understand. Then you have self-regulation, reflecting on one's own beliefs, thought process and conclusions. We'll presently see where the self-regulation belongs. And then create. You're proposing also proposing solutions better than what was presented is also part of critical thinking. So one aspect of critical thinking is proposing improvements on what has been presented to you. So as we can see from this, critical thinking involves understand, analysis, evaluate and create. A create here, thinking with a view to improving it. Okay, we are not producing a solution from scratch. How to modify a presented solution, because when we went through the analysis and evaluation, we found certain gaps and we are trying to fill that gap. That is also part of create. Self-regulation, by the very definition, it is metacognitive knowledge of a revised Bloom's taxonomy, which we will be exploring in the next set of units. So, as you can see, critical thinking involves multiple cognitive levels and multiple knowledge categories, all of them. So, to that extent, other than putting a kind of a putting all these elements together and say this is what we call as critical thinking, other than that, critical thinking is addressed through the 6 cognitive levels and the 4 knowledge categories of revised Bloom's taxonomy. So it is not something different than what is already present. That's why it is considered that it is not necessary to identify another cognitive level to represent critical thinking. Now, another word that is used is problem solving. We keep hearing statements like students are not trained to solve problems, problem solving is not their ability, and so on and on. That is part of the curriculum design. But is there anything called problem solving separately from the 6 cognitive levels? That's what we would like to see. And there are plenty of literature on problem solving by way of um, published books in this area, though not recently I haven't come across new books on problem solving. But when you put whatever material that is already in the published literature together, problem solving would involve several cognitive processes again. We may need conceptual knowledge to analyze the issue, then one can evaluate different approaches and then finally create a valid solution. So that is what is involved in problem solving. Problem solving is a cognitive process of identifying, analyzing, and resolving unfamiliar or complex situations by systematically applying prior knowledge, conceptual understanding, and critical reasoning. So when you look at the wording, once again, practically all cognitive levels are involved. But of course, it depends on the kind of problem that you are addressing. We may be looking at as a problem that has been already solved, but slightly incrementally more complex. It could be an incremental problem or altogether a completely unfamiliar new problem. So again, the problem solving addresses a much wider spectrum of issues. So to that extent, and if you look at the problem solving and revised Bloom's taxonomy, Within the framework of revised Bloom's taxonomy, problem solving spans multiple levels. That is very clear. From recalling relevant facts to creating innovative evidence-based solutions. That means all the 6 cognitive levels are involved. The order in which specific cognitive process and knowledge subtypes get used would depend to a great extent on the particular type of problem being solved and or the subject matter within which the problem was posed. So, problem solving involves all the 6 cognitive levels or all the 6 cognitive processes. So, what people try to argue beyond this, or is there something else that the student is expected to do? But as of today, we haven't come across anything outside these 6 cognitive activities that need to be performed to so-called solving a problem, or what you call problem solving. Now that brings us, because the whole the Bloom's taxonomy is now in its 2 avatars, you can say, is something like about more than 70 years old. A lot of what do you call critique that has taken place, and people have been continuously trying to add, because they are not fully happy with the 6 cognitive levels. So, if you ask the question, are additional cognitive levels needed? We don't know. First, right now, we don't know. As of now, in my view, we don't have any. If something else comes in future, yes, we don't rule it out. Critical thinking and problem solving do not involve activities that are not addressed by 6 cognitive levels. So, critical thinking and problem solving are not new cognitive levels. Then several researchers proposed additional cognitive processes at levels higher than create. But these have not yet been accepted by this community. The 2 things that I've come across, one is they consider innovation is a new cognitive level. Another one that is being proposed is entrepreneurship. Entrepreneurship is a higher cognitive level. That's what is said. But when we looked at the literature related to that, at least at present point of time, it is not convincing. But we haven't, other than the proposals, we haven't come across any other literature that that argues for it. But one thing right in the beginning, in 1956 itself, the Professor Bloom has stated, because we are trying to kind of categorize what is happening in the brain, and as we do not know adequately about the brain even today, so all taxonomies of learning are projects in progress. Yes, we do not rule out something coming in, but as of now, these 6 cognitive levels are the ones with which we work with. Okay. Now, again, because of the things that we are looking at, the boundaries between different cognitive levels, that is, at least adjacent cognitive levels, from understand to apply to analyze, and so on, are the very sharp boundaries. Can I have something like a formula or a very fixed set of words? If you use those words carefully, then the cognitive level is automatically can be identified. No, it is not like that. As we are trying to classify the functions of the brain with the limited understanding, the boundaries between cognitive levels are not sharp, but that does not diminish the usefulness of the taxonomy. Because when you write something, what do you call a learning objective or learning outcome, you may debate, does it belong to analyze or does it belong to understand? Because there are some common action verbs between analyze and understand as well. What does it be? How do I decide? And that requires looking at many more examples, truly understanding what are the sub processes of understand and how they, what exactly their meaning. It is not a trivial exercise. It comes over a long period of time, continuously debating with others on that. And similarly, the analyze. As I mentioned, analyze itself is a fairly, or to my knowledge, relatively new to the faculty community to use it appropriately as per the revised Bloom. So what happens is, the fact, after looking at that and trying to understand the intent of that particular thing, then only you should decide. So it requires some careful considerations in some cases. In many cases, it generally is obvious, but there are situations where you you can always debate whether it belongs to this category or the other category. Okay, so that uh, not having a very sharp boundary between cognitive levels is something that you have to accept. And besides, we do not have enough number of words in any language to represent all the nuances of associated with our cognitive activities. So we are working with what you may consider as limited number of words. So to that extent, judgment is required by educators to label a given activity by a cognitive level. For example, identify. What does it belong to? Just by that word, we cannot make a judgment. Look at the entire statement, whatever outcome that has been written, and debate on that. What exactly you want the student to be able to do based on that activity description. Then you can decide after debating whether it belongs to whether it is analyze or understand. Okay. These are the words that are used: higher orders of learning, deep learning, meaningful learning. These words are used by different educators. So they all, at least right now, we say they mean the same thing, all the three. And if you look at the cognitive levels, if you draw a line in the middle of apply, that is, apply has execute and implement. After apply, if you draw a line, anything that comes uh, above execute, that is implement and then analyze, evaluate and create, they all constitute higher orders of learning. Okay. And in fact, some people are even HOL and LOL, these labels are used while writing some what do you call learning outcomes in some courses. Some institutes follow that. We generally suggest that don't go by that labeling. You can directly talk about what is the cognitive level you are talking about. You don't have to keep saying, because HOL is important, then you label anything and everything you want as HOL. That's it. So please don't fall into the trap. Then there is another two concepts which are associated again with taxonomy: complexity and difficulty. Complexity refers to the cognitive demand of a task how mentally challenging it is based on the type of thinking required. Type of thinking, please remember that. In revised Bloom's taxonomy, complexity increases as one moves from lower order thinking skills to higher order thinking skills, that is, from remember to create. When I move upwards, we already mentioned there is a hierarchy. As we move upwards, the complexity of thinking is increasing. So, as we go up from remember to create, we are increasing the complexity. That's what we have to find. Then difficulty refers to how hard a task is for a specific group of learners based on factors such as prior knowledge, skill level, motivation, and learning support. Let us merely look at what another word that is used is cognitive load, or the amount of time that you take to solve an issue or respond to a particular question. That that represents the difficulty. For example, let us say you take a very trivial thing. You take what is the distance between your home and the office or home and the school. If you say that, it's easy to remember. Then if you say in the same town, you ask some from 10 destinations, and from one point to another how much time it takes, from that point to this point how much time it takes, each one you may guess. But if you are asked to write down all the numbers at one time, obviously it will take time and it is difficult. Even at a trivial thing like remember, cognitive level. So it depends on the number of tasks that you have to perform, or the amount of time that is available, or the type of items that you have, and that is what increases the difficulty. Difficulty is a question that we would attempt in the one associated course on the assessment. Now you have the difficulty and complexity are not the same. They are two different dimensions. So to that extent we can have high complexity, high difficulty tasks. You can have high complexity and low difficulty tasks. And you can have low complexity and high difficulty tasks. And low complexity and low difficulty tasks. And there is some kind of a confusion with this. We have seen that those arguments by majority of the faculty in various institutions, that saying that the students they get are not cognitively capable of addressing high complexity tasks. So to that extent, you completely eliminate from your assessments anything connected with high complexity. That is, higher cognitive levels you do not touch. The way you question, always you confine yourself to the lower cognitive levels rather than address anything at higher cognitive levels. Now that we consider that is being unfair to the students. They need to understand higher cognitive levels. So high complexity should not be removed from that. But what you can do, play with, you can give low difficulty tasks if the students are not capable of. But high complexity should never be removed from the teaching and learning processes. Then you are preparing them for a world for which they are not, you are not preparing them for the world in which they have to participate. As we all know that all industries complain at the time of employment the students are not capable of performing certain things. And one of those things is because by either design or by tradition, we have been avoiding high complexity tasks from assessment. If you are not part of the defined assessment process, why would the students prepare for that? That means even good students are prevented from uh, performing tasks at high complexity tasks. So please, though it looks somewhat trivial, but this has been the phase of our undergraduate curricula, or the way the uh, what do you call assessment and instruction is conducted. For variety, whatever be the excuses or reasons, but what has happened is high complexity or the higher orders of learning are kind of pushed aside. Now, coming to nature of courses in engineering, again we want to look at it from the way we have courses from revised Bloom's taxonomy point of view. First of all, most of the courses offered in engineering programs are designed and offered in well-defined frameworks. There are no ambiguities. We are not talking of any course that is at the frontier of science or engineering. So, where there is a completely accepted what do you call premises and methods, everything is within well-defined frameworks. There is no ambiguity. And solution of open-ended problems is attempted in engineering programs mostly through projects and sometimes through assignments where time for solving is not a major limitation. Fortunately, this has happened in recent times when you have some 20% weightage given to for internal evaluation and 80% to one single end semester examination, for whatever be the history for that, it doesn't give you much choice. And many times even the 20% internal evaluation is also dictated by the university, what kind of structure it should be. And to that extent, you have a high stakes 3-hour examination that tests the student, and obviously the assessment cannot, as we have shown also, you cannot include assessment items that belong to higher cognitive levels in a limited time examination. Fortunately, many institutions are shifting towards 50-50. 50% for internal evaluation and 50% for that. But even that internal evaluation, one has to be careful to have adequate weightage given to kind of assignments where you can attempt to address higher cognitive levels, but that requires a lot of preparation by the faculty in advance to make it really meaningful. And there is another issue. When the assessment context is identical to the instructional context, what it means is I solve a problem in the class, I go through all the steps, I demonstrate that. Either I ask the same problem in the examination, or with a very trivial change in that, I ask the same question in the examination. Especially if they belong to remember and understand, we are likely to keep using the same questions repeatedly. And in that case, the cognitive level doesn't matter. Whatever be the labeled cognitive level, it is effectively people mug the answers for those questions and remember that and reproduce that. So you are officially bringing all cognitive levels to the remember level, to the one lowest cognitive level. So these are all the issues that one needs to remember about the way our engineering programs are conducted and what are the important issues that important aspects that we are missing out, and what can be done by you as individuals in your courses. And in the next week of units, we try to understand the categories of knowledge in revised Bloom's taxonomy and the Vincenti categories of engineering knowledge. That is for the next week. And thank you very much for your attention.